It is given that a plank with a bar placed on it performs horizontal harmonic oscillation with an amplitude of 10 centimeter. So just consider that we are having a plank and an object of mass m is kept over it, and this system is in simple harmonic oscillation. Find the coefficient of friction between the bar and the plank. Let's say coefficient of friction is mu. If the former starts sliding along the plank, when the amplitude of oscillation of plank becomes less than the amplitude which is given as something but 10 centimeter, and the time period is given as something but 1 second. So we can just consider that, let's say the particle is at its extreme position. So we can write the forces acting on these objects will be the frictional force exerted by the plank, which is behaving like a restoring force. So we can write as that frictional force is F, and just consider that its mass is m, and this is moving with an acceleration, let's say that is equal to e, and take it as this one is at a distance a from the mean position, which is nothing but the amplitude of oscillation. So you can write the equation for it, that is net force is equal to mass into acceleration. Mass you can take it as m, and acceleration we can take it as a. Now we know that when the particle is at its extreme position, the value of this acceleration will be maximum, that will be equal to omega square into amplitude of oscillation. And this frictional force we can take it as mu into normal reaction, that should be equal to m into a is omega square into a. And this normal reaction we can take it as mg, that should be equal to m into omega square into a. So we can cancel m. So we can write the equation for this mu is equal to nothing but omega square a divided by g. Now over here the value of omega we can take it as nothing but 2 pi divided by t. So if I substitute in this value, the value of mu becomes 4 pi square t square into a divided by g. So if you are substituting the values, then we'll get the value of this coefficient of friction, that is around 0.4.